लास्ट टाइम हमने किया था लॉ ऑफ कंजर्वेशन ऑफ एनर्जी और हमने उसका एग्जांपल भी एक किया था. नाउ वील डू पावर. लेट अस सी व्हाट इज पावर, हाउ वी डिफाइन इट. In this case, power is defined as rate of transfer of energy or rate of doing work. यानी कि आप हमने अगर पावर कैलकुलेट करनी है, either divide work with time or divide energy with time, and the units will be watt. That is 1 joule per second. अगर ट्रांसफर हो रही है तो you develop a power of 1 watt. ये इसका फॉर्मूला है. Now in this case, definition of watt is very important. Power of 1 watt is developed कब? अगर रेट ऑफ ट्रांसफर ऑफ एनर्जी या रेट ऑफ डूइंग वर्क जो है वो 1 joule per second होगा. इट इज 1 watt. In this case, how to calculate power? For example, we have a student, a boy who runs 50 kg, whose mass is 50 kg, and he runs up the height 5 meters in 10 seconds. What is the power developed? In this case, the work he has done is mgh, gain in potential energy. So we can replace work by mgh, F into D, and 50 into 9.81 into 5. This is your work or gain in potential energy. Divide by time. Time is 10 seconds, and you get the answer for the power as 245 watt. So power basically means rate of doing work or rate of transfer of energy. This is the basic formula of power. But here we are going to find the power required to move an object with a constant speed, and this is also power. But we are maintaining the speed. So how much power do we have to apply? Formula is same, work over time. Work is F into D into T. We want to maintain constant speed. How much power required? If you divide d by t, it is basically your velocity. That is, you have an object. We have to apply a forward force. There is a backward force. And because of these forces, the object starts to move with a maximum constant velocity. So what forward force is required should be equal to resistive force. And in this case, as the speed is constant, so d over t can be replaced by v, and therefore the formula for power becomes F into V. Power is work over time, but if we want to move an object with constant speed, then the power can also be calculated as F into V. F into V is the power required to move an object with constant speed. So here we have another formula for power, and the derivation of F into V is also in your syllabus. Let's find the question. Okay, let's see this as well. But generally they don't ask us questions, but we can also. For example, if we don't have a constant force and they have given a graph for F and D, in that case, we'll find the work for a very small distance where the value of F is almost constant. We take the average value of force and the work will be F dot ds. But if we want to find out the total work done, it will be calculated by mathematically. हम इसको इंटीग्रेशन कहते हैं, बट आपसे कोई पूछेगा नहीं. आपने सिर्फ ये समझना है कि अगर फोर्स और डिस्टेंस का ग्राफ दिया हुआ हो आपको, तो आपने एरिया अंडर द ग्राफ निकालना है. वट एवर इज द शेप. एफ और एस का ग्राफ दिया हुआ है अगर आपको, तो जस्ट फाइंड द एरिया अंडर द ग्राफ. दैट विल बी द वर्क डन. इसमें अब एरिया निकालने के लिए आई कैन चूज डिफरेंट शेप्स। जैसे मैंने यहाँ पे दो ट्रेपीजियम चूज किए हैं, इन दोनों का एरिया निकाल लें। दैट इज अप्रॉक्सीमेटली वर्क डन बाय दैट फोर्स। तो अगर तो रेगुलर शेप है, वेल एंड गुड। अगर रेगुलर नहीं है तो उसमें आपने अप्रॉक्सीमेट एरिया निकालना होता है बाय चूजिंग रेगुलर शेप्स योर सेल्फ।
सर अगर सपोज
जैसे कि आप दो
इंटीग्रेशन आती हो तब कैन वी यूज इंटीग्रेशन?
इंटीग्रेशन, वो आपको इक्वेशन नहीं देगा ना, इस लेवल पे वो आपको इक्वेशन नहीं देता। वो सिर्फ आपको ग्राफ देगा, कहे जी इसका बताएं वर्क कितना है। जैसे कि फॉर एग्जाम्पल ये ग्राफ है, वो कहते हैं ये बताइएगा 15 सेकेंड्स में कितना वर्क हुआ, सॉरी 15 मीटर्स ट्रेवल किया ऑब्जेक्ट ने, तो कितना वर्क हुआ।
ठीक है सर।
आप सिंपली इस ग्राफ का एरिया निकाल लेंगे। इट्स अ ट्रेपीजियम, हाफ सम ऑफ पैरेलल साइड्स इनटू हाइट। तो एक पैरेलल साइड तो 15 हो जाएगी, दूसरी जो है वो 6 से लेके 10 तक है, वो 4 हो जाएगी, और इसकी हाइट जो है वो 3 है। क्लियर? So just find that, and that is also your work done divided by time, that is work power.
ओके
Sorry,
सर।
work calculated. Okay, next up देखते हैं question. Let's see some questions. Okay, find the question. We have a student who is at a height of 4 meters. He's a child on a surface of slide. 4 meters हाइट है, वहां से नीचे आ रहा है। वो कहता है व्हाट्स द डिफरेंस ऑफ ग्रेविटेशनल एनर्जी फ्रॉम एक्स टू वाई। सो एम जी एच वन पहली एनर्जी, माइनस एम जी एच टू दूसरी एनर्जी। इनका डिफरेंस निकाल लें, यू विल गेट द डिफरेंस इन ग्रेविटेशनल पोटेंशियल एनर्जी। एम जी गिवन यू टू यू एज 330, 4 minus 1.1, and you get the answer. This much is the change in gravitational potential energy. वो कहते हैं जी एवरेज उन्होंने हमें दिया हुआ है दैट द काइनेटिक एनर्जी ऑफ द चाइल्ड एट वाई इज 540। रिमेंबर, आपके पास जो चेंज पोटेंशियल एनर्जी आ रही है अकॉर्डिंग टू लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, इट मस्ट हैव बीन इक्वल टू गेन इन काइनेटिक एनर्जी, but it is not. Why? Because in this case, frictional force are not negligible. So sum of your total energy is converted into work done against friction, and the remaining energy becomes your kinetic energy. अब वही ये पूछ रहा है कि जी बताइएगा कि कितना डिस्टेंस मूव किया है, जबकि एवरेज फ्रिक्शनल फोर्स आपको बता दी है 52। सो यहाँ पे मैं लॉ ऑफ कंजर्वेशन ऑफ एनर्जी अप्लाई करूंगा। लॉस इन पोटेंशियल एनर्जी इज इक्वल टू गेन इन काइनेटिक एनर्जी प्लस वर्क डन अगेंस्ट फ्रिक्शन। जो इनका डिफरेंस होगा वो फ्रिक्शन के अगेंस्ट आपने वर्क किया हुआ है, तो भी उसको वर्क डन अगेंस्ट फ्रिक्शन हम पुट कर सकते हैं। पुट द वैल्यूज। सो 960 minus 540 will be your difference in potential energy and kinetic energy, which comes out to be 420. This much is the work you have done against friction. F into D. Force is given to us, average force. Distance we have to calculate.
सर इन दी पार्ट ए हमने ग्रेविटेशनल फील्ड स्ट्रेंथ की वो क्यों नहीं इंक्लूड की
क्या
वैल्यू?
चीज?
तो ग्रेविटेशनल
बेटा
फील्ड
ये
स्ट्रेंथ की।
हाँ, उसने वेट दिया हुआ है आपको mg।
अच्छा। ओ ओके ओके ठीक है सर।
इट्स नॉट mass, it is mg.
ठीक है सर।
So from here we get the value of d, 8.08, और अगर मैं राउंड करता हूं तो वो 8.1 बन जाता है। नेक्स्ट पार्ट में कहता है जी कि ये बच्चा जो है वाई पे से जब जाता है तो वहां पे कोई वो जंप सी है, तो वो जब वाई पे पहुंचता है उसके बाद वो एक उसी वेलोसिटी से आगे मूव कर रहा है और एक प्रोजेक्टाइल मोशन बनाता हुआ स्विमिंग पूल के अंदर जाके गिरता है। द वेलोसिटी इज 40 एट एन एंगल ऑफ 41 डिग्रीज। वो कहते हैं व्हाट इज द स्पीड ऑफ द चाइल्ड। तो जो y पे हमारे पास काइनेटिक एनर्जी है वही उसकी स्पीड क्रिएट करेगी। तो हम यहाँ से काइनेटिक एनर्जी को हाफ एम वी स्क्वेयर लगा के v की वैल्यू कैलकुलेट कर सकते हैं। काइनेटिक एनर्जी वॉज 540, mass will be 330 divided by 9.81। तो y पे जो वेलोसिटी होगी वो जो काइनेटिक एनर्जी उसके पास है उसी की वेलोसिटी होगी। यहां से मेरे पास v की वैल्यू 5.7 आती है। अब वो कहता है व्हाट इज द वेलोसिटी एट z। इट्स अ प्रोजेक्टाइल मोशन, रिमेंबर। जैसे जैसे ऑब्जेक्ट ऊपर जाएगा उसका वर्टिकल कंपोनेंट ऑफ वेलोसिटी कम होकर जीरो हो जाएगा, बट द हॉरिजॉन्टल वेलोसिटी विल रिमेन सेम। तो यहां पे z के ऊपर उसके पास जो वेलोसिटी है दैट इज द वेलोसिटी विच इज हॉरिजॉन्टल कंपोनेंट ऑफ इनिशियल वेलोसिटी, दैट इज v cos 45, and it will remain constant even when it hits the water. So v cos 41 is the value for the velocity at z or horizontal component. Put करें values, and from here we get the answer. So at z the velocity comes out to be 4.3. An object falls vertically from rest थ्रू एयर मेंशन कर दिया उन्होंने, इसका मतलब है वहां पे एयर रेजिस्टेंस इज प्रेजेंट। एनर्जी कन्वर्जन्स, लॉस इन पोटेंशियल एनर्जी ड्यू टू लॉस इन हाइट, gain in kinetic energy due to gain in speed, and there is also increase in internal energy due to energy lost against resistive forces. So आपने सारी जो एनर्जी कन्वर्जन पॉसिबल है बिकॉज एयर कहा हुआ है तो रेजिस्टिव फोर्सेस आर देयर, सो सम ऑफ द एनर्जी विल बी लॉस्ट अगेंस्ट रेजिस्टिव फोर्सेस। वो कहते हैं हमारे पास बॉल जो है उसका मास 150 ग्राम्स है, उसकी इनिशियल स्पीड जो है वो 25 मीटर्स पर सेकेंड है। व्हाट इज इनिशियल काइनेटिक एनर्जी, उसके लिए हम लगाएंगे हाफ एम वी स्क्वेयर। मास को किलोग्राम में कन्वर्ट करना है हमने। वेलोसिटी इज 25 square, and we get the value of initial kinetic energy. तो कहते हैं जी बॉल goes to a height of 21 meters. तो what is the loss of energy of the ball to air resistance? It has 47 joules of kinetic energy. Goes to a height of 21 meters. So first of all, we have to find the value of potential energy, mgh. If there is no loss, then mgh should be equal to 47. But it comes out to be 31 joules. So that means 41 minus potential energy is the value of energy lost against friction. That means 47 minus 31. This much energy is lost against friction. What is the force? Remember, the friction only acts when the object is moving, and the distance the object has moved is 21 meters. So F into D is your work done against friction. F we have to calculate, distance will be 21. And from here, you can find out the value of F as 16 divided by 21, which comes out to be 0.76. So if there is some friction, then we have to keep in mind that some energy will be lost against resistive forces or friction. We have to consider that in the equation of energy. Distinguish between gravitational potential energy and elastic potential energy. Definitions: due to the position in a gravitational field is gravitational potential energy, whereas energy possessed by a body due to change in state or shape, deformation, extension, or compression, that is called elastic potential energy. That is half F into E is the formula. You should remember that as well because We are going to use that in some questions. A ball of 65 grams is thrown vertically upwards and the speed is 16 meters per second. What is initial kinetic energy? Half mv square. We get the answer. Up here they have mentioned that air resistance is negligible. No air resistance. So kinetic energy will be equal to potential energy because there is no air resistance present. So there is no energy lost against resistive forces. So from here, we get the answer for velocity. You can use v square 2gh or you can use equation of motion as well. A will be constant as 9.81. Simplify that and you get the value of h. In this case, it comes out to be 13 meters. Now, this is the interesting part. What's the ratio of potential energy and kinetic energy when the ball has traveled half the time? If it has traveled half the time, height will not be half because the object is not moving with a constant velocity, it is decelerating. So for half the time, the value of h will not be half and the value of kinetic energy will also be not half. So how to do that? First of all, we have to find the value of time. V minus u over a. So time comes out to 1.63 and using half the time, we'll try to find out the value of height. Total height was 13. So how much distance it travels in 0.815 seconds? We can use the formula S is equal to ut plus half at square because initial velocity is not 0. Initial velocity is 16. Time is now 0.815. So from here, we find the value of h and it comes out to be 9.78. So potential energy will be due to the height of 9.78. Total height was 13. So potential energy plus kinetic energy is equal to total energy. इतनी हाइट की हम निकाल लेंगे पोटेंशियल एनर्जी और मैक्सिमम एनर्जी जो है उसमें से अगर आप पोटेंशियल एनर्जी माइनस कर दें तो यू विल गेट द वैल्यू ऑफ काइनेटिक एनर्जी. तो यहां से हम डिफरेंस ऑफ हाइट निकालेंगे बिकॉज द डिफरेंस ऑफ पोटेंशियल एनर्जी विल बी इक्वल टू काइनेटिक एनर्जी. जितनी हाइट आपके पास है वो h1 है, टोटल हाइट में से माइनस माइनस कर दे तो यू विल गेट द वैल्यू ऑफ काइनेटिक एनर्जी बिकॉज दिस इज अकॉर्डिंग टू लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. So U will be equal to mgh1 and kinetic energy will be mgh minus h1. इसको बल्कि थोड़ा सा कहते हैं मॉडिफाई करता हूँ मैं यहाँ पे ऐड कर लेता हूँ. जस्ट गिव मी 1 सेकेंड. इक्वल टू दिस. So you can use this simple law of conservation of energy कि जो आपके पास टोटल एनर्जी है उसमें से आपने U माइनस करना है कौन सा जो कि h1 की हाइट की का पोटेंशियल एनर्जी है. तो जो बाकी बचेगा दैट विल बी योर काइनेटिक एनर्जी. लॉ ऑफ कंजर्वेशन ऑफ एनर्जी अप्लाई किया मैंने यहाँ पे एंड द आंसर कम्स आउट टू बी 3.26. State explain the effect of air resistance on the time taken for the ball to reach maximum height. If there is no air resistance, it will take less time because deceleration will be greater. But if there is air resistance, the time will be even shorter because now deceleration will be greater. Because resistive force will increase. It will not only be resisting force will be weight plus it will be also the resistive force of air resistance. So resultant force increases, and if resultant force increases, deceleration increases, And if deceleration increases, in that case, it will take less time to reach maximum height. This is the logic behind without air resistance and with air resistance. Okay, one more question. What is power? It is rate of doing work or rate of transfer of energy. How to prove? It is the product of force and velocity. Start from here. Work is F into D. It is moving with a constant velocity. So D over T is V, and we get the answer F into V. They say that we have a trolley and it is moving with a constant speed. The force due to air resistance is negligible. It is moving on inclined plane of 9 degrees. How much power is required? F into V. But what should be the force? In this case, it has backward force equal to the component of the weight. Remember, component of weight down the slope is always mg sine theta. That is the force acting backwards. Forward force should be equal to mg sine theta so that it moves with a constant velocity as resultant force will be equal to 0. So for this, F is equal to mg sine theta and we multiply by velocity which is 8.5, we'll get the value of the power. So backward force is mg sine theta, forward force should be equal to backward force. And from there, we get the answer as 32,600. And if we to 260 different figure, it becomes 33,000 watt. But we want the answer in kilowatt. So it will be 33 into 10 raised to power 3. That means it is 33 kilowatt. State two reasons why the rate of change of potential energy of the lorry is equal to the power calculated. Why it is equal to power calculated? Because the only gain energy with time is potential
Negligible.
energy. हाँ दोबारा बोलिएगा.
Resistance is negligible.
Yes, resistance is negligible. Secondly, the velocity is constant. That means the object is not gaining any kinetic energy. तो सिर्फ और सिर्फ पोटेंशियल एनर्जी गेन कर रहा है इसलिए वो बराबर आ जाएगा. तो एक पॉइंट तो आपका बिल्कुल सही है दैट देयर इज नो एयर रेजिस्टेंस सो नो लॉस ऑफ एयर अगेंस्ट एयर रेजिस्टेंस. Secondly, kinetic energy is constant, so only potential energy is gained. Okay, जी, one more question. Okay, जी, what is meant by work done? It is the product of force and distance moved in the direction of the force. State a word equation that relates F to on B on the change of potential energy and kinetic energy, and they say there is resistive forces here. So loss in potential energy will be equal to gain in kinetic energy plus work done against resistive forces. Now they have given us a velocity time graph of the boy on the board. From the graph, we can find out any velocity for any time. For example, if we say what is the velocity at 2.5 seconds, आप 2.5 seconds से vertical line draw a horizontal line, and you will get the value of velocity for 2.5 seconds. Why? Because in the next part they have asked about it. Show the distance moved down the slope is 9.3 in a time of 2.5 seconds. Area under the graph. So it comes out to be 9.3. Gain in kinetic energy half mv square. Initial velocity was 0, final velocity 7.4. Mass is given to you as 75. Loss in potential energy, mgh. We know that the inclined plane is 9.3. That is not your h. H is your vertical height. And vertical height can be calculated as 9.3 sine 60 by using trigonometric ratios. So for mgh, h will be your vertical height, that is 9.3 sine 30, and you get the answer as 3400. Gain in kinetic energy is less, loss in potential energy is greater. The difference will be work done against resistive force to find the difference, and that is F into D. Distance is 9.3. And using this, you can find out the value of resistive forces. It comes out to be 150 in this case. Next question. We have a bullet. It hits a hanging block, and both bullet and the block rises to a height of 8.6 centimeters. Bullet is 2 grams, wood is 600 grams, and as both rises, what is the gain in potential energy? It is mgh. Mass in kilograms, height in meters. So gain in potential energy was 0.51. What is the initial speed of the block and the bullet after they began to move off together? The speed is the kinetic energy of the bullet and the block. That energy is converted into potential energy. So यहाँ पे मैं loss in potential energy is equal to gain in kinetic energy को equate करूंगा because यहाँ पे resistive forces act नहीं कर रही थी. Half mv square is equal to mgh, or v square is equal to 2gh. That means v comes out to be 1.3. In this case, we have to prove that. So straight away kinetic energy is equal to potential energy. This was the kinetic energy after the impact when both of them were moving together. Apply principle of conservation of momentum to find the speed of the bullet before of the impact. We know that the speed of bullet and block after the impact is 1.3. अभी कैलकुलेट किया हमने. तो यहां पे हम लगाएंगे m1 u1 plus m2 u2 should be equal to m1 plus m2 into v. Initial momentum of the block was 0. तो यहां पे mass of the bullet is 2 grams and velocity is to be found. Final velocity is 1.3. So 2v is equal to 602 into 1.3, and from there you can find out the velocity of the bullet before it impacts. It is 390. Now they ask us, what is the kinetic energy of the bullet? Half mv square. It comes out to be 152. Is it an elastic collision or inelastic collision? The rule says if kinetic energy before is equal to kinetic energy after, it is elastic, otherwise inelastic. This is your kinetic energy before impact, and we have calculated the kinetic energy after the impact. It was only 0.51. Is it elastic? No, it is not elastic because kinetic energy before is not equal to kinetic energy after the collision. Therefore, it is an inelastic collision.